Hi everyone. We're going to be talking about rational exponents and radicals. So let's go ahead and review the parts of a radical. Now you should have this already, this handout, and this is going to go in your interactive notebook. So let's go ahead and write down just a number here, and let's say this is the cube root of 10. So this number is called the index. Okay, this number right here, and this number down here is called the radicand. And of course, this symbol right here is the radical sign. This is the radical. Now, if the index is not written, it is automatically a 2. So if you have, say, the radical of 10, then it's just assumed that this number is 2 and this is the square root of 10. Okay, but normally if it's a square root, we don't need to put a 2 here. Okay, but if it's anything other than the square root, then we need the number to let us know what root we're going to take of the number which is inside the radical. So this would be the cube root of 10. If a 4 was here, that would be the fourth root of 10. Okay, and so for the other side of the handout, let's write down, just determine the index and the radicand. So for example here, for the first one, the index is equal to 2, and the radicand is equal to 24. Now, what about if there's a variable expression inside? Okay, here the index would be 4, so you're taking the fourth root, but the radicand is everything inside the radical sign, so this would be 1, 28, and to the 8. Okay, so just to pick one and do, go ahead and do one more on your own. Then let's go to the next handout, which is also going to go in your interactive notebook. And this is converting between radical form and rational exponent form. Okay, so here the radicand is x, but x is going to have an exponent. So I'm going to write an e for the exponent, and I'm going to write an I for the index. Okay, so let's go ahead and write down, this is the index. And then here, the radicand happens to also have an exponent. So when you have a radical, you can convert it to a rational exponent form. Now let's go back to rational, and what math word do we see here? Ratio. And another word for ratio, you can write a ratio also as a fraction. Okay, so rational means writing the exponent as a fraction. Now, we've got the variable I to represent the index and the e to represent the exponent. And you probably have heard that song, Old MacDonald Has a Farm. And the next part goes E-I-E-I-O. So E-I-E-I-O. So E is going to go on top, and I is going to go on the bottom. So for example, if we had the cube root of x squared, this would be the same as, well, this is going to be my I, this is my E. I think to myself, Old MacDonald had a farm. E-I, so the 2 is going to go on top, and the 3, the index, will go on the bottom. Okay. So this is going to be in your interactive notebook on page 21. And the one that we just did, this one is going to be in your interactive notebook on page 20. So just go ahead and make sure that this ends up on page 20 and the next one ends up on page 21. Now on page 21, this is a half a sheet. So what we're going to do is we're going to do a few practice problems to make sure you get the hang of converting back and forth. So let's do some examples underneath your that little half sheet. Okay. Okay, so let's do some examples here. Okay. Suppose I had the square root of 10. Okay. So I want to go ahead and let's do a couple on our own, and then I want to ask you to do a couple. A couple together, and I'll ask you to do a couple on your own. So in this case, what is the index? Well, there is no number here, so it's an assumed 2. And there is no index here. No exponent here, so we're going to assume that there's a 1, okay, an invisible 1. So Old MacDonald had a farm, EI, so that's a 1, and then a half. So EI, EIO. So the exponent goes on top and the index goes on the bottom. All right, suppose you had, say, the cube root of n to the 4th. What would that equal? Well, the base is n, and then the 4, well, the index is 3, the exponent is 4, the 4 is in the numerator, and the 3 is in the denominator. All right, go ahead and try the next few on your own. Okay, number 3, you're going to try 1 over the 5th root of 2. Number 4, 1 over the cube root of 3. And number 5, the 4th root of 27. Okay, so let's go ahead and keep the fraction as it is, but we're going to take the denominator, and remember that this is the exponent here, which is a 1, and the index is a 5, so we're going to write it as EI 1/5. Now, because it's in the denominator, let's write it as a power of 2 and not in a fractional form. So remember this when you talk about if it's in the denominator and you want to move it to the numerator, you just turn the exponent to its opposite. In this case, it's positive, so we're going to write it as a -1/5. For number 4, very similar. We're going to write 1 over, and this is exponent, which is a 1. So this would be 3 to the 1/3. And we're going to write it as a power of 3. So this is going to be 3 to the -1/3. Now, 27 for this one. Okay. We're going to write 27 as a power of 3. And so in this case, it's 3 times 3 times 3, which is 3 to the 3rd. So let's go ahead and write it as the 4th root of 3 to the 3rd. And that's going to be equal to 3, oh gosh, I can't really see where my mouse is here, my pen, oh there it is, 3 to the 3, the exponent is a 3, and the index EI is a 4. Okay, okay, let's do a few more. You're going to have to know how to use a calculator to approximate fractional exponents. Okay, so suppose we have, what number were we on here? Let's see, this was number 5. Okay, so we're on number 6. Okay, So if you're given 2 to the 7th eighth and you're asked to use the calculator to approximate it, 2, and then we're going to do exponent. So we're going to do the caret symbol right here. And in order to get a fraction, you can just type in 7 divided by 8, or if you have the new operating system, you can choose to write it as a fraction by pressing alpha y equals, and we can put a 7 in the numerator and 8 in the denominator, and we press enter and we get approximately 1.834. So we're going to write approximately 1.834. Okay. Okay, so my smartboard software is going a little nutty, so we're going to use the document camera here. So I can move this out of the way. Okay, we just have a few more examples. We approximated 2 7/8 as a decimal. So let's go ahead and, I can't remember what number that was, but let's do 8 5/3. Okay, and then 25 3/2, and 125 to the negative 2/3. Okay, so go ahead and try those and submit your responses, and then we'll go over them. Okay, so 8 is the cube root of 2, so I'm going to write it like this. But you have this to the 5/3. When you take a power to a power, you multiply the exponents. So here, 3 over 1 times 5 over 3. The 3's cancel, and you're left with 2 to the 5th. For 25 to the 3/2, 25 is a perfect square, so we can write it as 5 squared to the 3/2. Again, we can write the 2/2 as 2 over 1. The 2's cancel. Anything from the top can cancel with anything from the bottom when you're multiplying, and that is 5 to the 3rd. And the last one, 125, is equal to 5 times 5 times 5, so therefore that's 5 to the 3rd times negative 2 to the negative 2/3. Again, we multiply because it's a power to a power, and we get 5 to the negative 2. All right. On the other side, if you don't have room, okay, and in your interactive notebook, but continue writing in your interactive notebook. This is page 21. Okay, so we're on page 21 here, and you're probably on the other side by now. We're going to solve exponential equations. So write this down in your interactive notebook. Okay, to solve exponential equations, there are 2 steps. 1, make sure the base is the same on both sides of the equation. Okay, number 2, then equate the exponents. And then solve for the variable. And solve for the variable. Okay, so let's try a couple examples. Okay, number 1. Let me just move this document camera. Okay, number 1, examples. Okay, 1. If you have 2 to the x is equal to 8, the bases are not the same, but we know 8 is equal to 2 to the 3rd. Once the bases are the same, you're going to equate the exponents, and that one's really easy because the variable is already solved for. Okay, number 2, suppose you had 1/7 to the x equals 49. Okay, definitely not have the same base, but it looks like you could write it with the same base if the base was 2. This would be 7 to the negative 1. And we know 7 to the negative 1 is 7 to the negative x equals 7 squared. We're going to equate the exponents, and that means that x equals negative 2. Okay, try one on your own. Number 3. Let me pick one out from the book here. Okay. Oops. Suppose we had Suppose we had 1/4 to the 1 minus x equals 32. Okay, go ahead and try that on your own. Okay, so we can write 1/4 as 1 over 2 squared. We can write 32 as 2 to the 5th. We're not there yet. We want to make this so that it's in the numerator. So that's going to go 2 to the negative 2. 1 minus x equals 2 to the 5th. And then we're almost there. We just have to multiply 2 by 1 over x, and that equals 2 to the 5th. Oops. Now we have to equate the exponents, and I'll do that next door here. So, negative 2, 1 minus x equals 5, and this is just algebra here. And we get x equals 7/2. Okay, oh no. I don't think I was in the recording. Sorry about that. There we go. Okay. Did you guys see that? Probably not. Sorry, I was outside the recording rectangle. So now you can see all the steps. 2 to the negative 2 to the 1 minus x. And then this is a power to a power. So you're just multiplying negative 2 times 1 minus x. And then you equate the exponents. Okay. Hopefully you will be able to complete these problems, and we will go over them in class. Good luck. Bye.